Hi everyone. In this video, we will look about the variant data type and how variant data type brings flexibility to the Spark ecosystem, especially when dealing with semi-structured data like JSON, right? So I will high level right first start with a variant table. So let us create a variant table, right? Now the table has two columns, id and then the customer, which is a variant column. Inserting data into a variant column, there are two approaches. First, let us see the easiest one. So let's assume we have the sales. We have two columns, id and customer, and customer is a JSON which is embedded as a string in your column, right? So we have to use this par JSON method which will convert any string like JSON into a variant type. So once you run this query, you will see the data is getting inserted into variant, right? So on a high level, it is nothing but a variant is a data type which holds semi-structured data like JSON in a more optimized format rather than storing it as a string. Now let us see how we can do it in an actual scenario. So for simulating the actual scenario, right, I have basically did I have two JSONs, right? So let me show you the JSONs first, right? So if you see here, I have created a volume YouTube demo, and under that demo, I have kept two JSON files. Let me see if I can quickly show the volumes as well. So once we open the volume folder, you have two files. So let's assume, right, this is a normal scenario, right, where we have some API, right, and each API might have a version. So this is the version one of data where you have ID, name, and address is a nested field, right? So once you click on this, right, again, so this is the first file, and the next file is again, right, assume the API has changed to version 2 and the address field has become an array, right? So this is a simple example. So if I give a display, right, as you can see here, right, there are two rows are there, right? One is your version one data, which is a normal address as a struct, which has street, city, zip, and second one is your array of address, right? Now, what is the problem with JSON, right? So how will you fix a schema for this, right? Assume you first give the schema as array, right? Address as an array column. So if you read the data with array, what will happen is basically, right, you will eventually end up reading one of the file, right, the version 2 which is in correct state, but as whereas the version 1 which is not an array, it will give null. So let us do the other way around, right? So if you again do the other way around, where you keep the column as a struct instead of an array, you will see the other scenario where the version 1 will be null and then version 2 will be having a, sorry, version 2 will be null and version 1 will be having a valid data, right? So this is one of the main problem with JSON data, unless the other formats like Avro and other types where you can basically have a union of data types, right? So first cases like it can be an array or it can be a struct, right, depending on the version, right, which is being read. So how does, now let us see how variant solve the data, right? So in order to read the data as variant, right, so if you read as a normal text file, right, so instead of reading it as a JSON, right, you can read as a text file. But however, when you read as a text file, as you see here, right, you will get the JSON spread across rows, right, depending on the new line. So there is one more way to read where you have an option, right, you can give whole text is equal to true. So if you give this format, right, it will basically load the data into a like single, like for each of the file, right, it will create one row. Basically each file in your each JSON file will be a single row. So if you read this one, as you see here, you are getting the entire row in a single entire content in a single row. Now, in order to load the or convert the data into variant, you can use the same as above, right? You use the parse JSON, you use this value column, and now it will be converted to a variant data type. So once you display this, it will be a variant type variant, right? So now with this, we are able to successfully read your data, which is a JSON, and then convert it to a variant, right? Now let us store this data. So you can store this data. You like I'm creating a table sales variant where we have a variant data as column and the type is variant, and you can basically insert this into your table, right? Now, if you are using Databricks, there is one more way. You have a copy into command. With that copy into command, also you can give the options like this, and then it will be inserted. I'll just skip this part because the same row will be duplicated, right? Now, let's say we have loaded the variant data, right? So it is a unstructured data or a semi-structured data. Basically, we have to manipulate it, right? We have to extract the content of it, right? So how can we do it? So one option is, right, variant doesn't have a schema overall, right? So you have to know, or you can explicitly, you can basically define your path. Say for example, right, based on the data what I see here, right, that variant data, right, it is having under variant data you have address, right, and under variant data you have column name and then version, right? So for querying a direct field you can use the colon notation. So for example, variant data colon version, right? And if you want to do use it in a filter, right, by default, right, if you use variant dot version equal to 1, right, where I want to filter for version equal to 1, it will throw an error. It will throw an error because variant is of type binary. However, we are basically trying to read that or compare that with a int number. So double colon is nothing but your cast operator, right? So this will just cache the data. So this is same as, right, you can basically this is same as you are casting normal, right? Cast as column as int, right? The same thing. So now with this we are able to filter the data or parse the variant, right? Now again, in that variant, right, if you want to do a query a nested field, right, it will follow the same struct notation. So you will basically use variant data colon address. So this will give me my address field, and inside that address, right, I have an array column, right, because address is an array. If you see my version 2 of the data, right, you have address which is again like an array, right? So you have multiple address, right? So you can use variant I mean like use the array expression. What is that? Yeah, you can use the array expression, and then you can use dot notation for the struct field inside that, right? So it is similar as how you query the normal JSON data. Just a variation is you just have to basically do a explicit cast and do the manipulations as and when it is needed, right? Remember this, for querying the variant schema access, you will use colon. For querying any fields inside the variant schema, right? Like say you have an array of struct or something like that, you will use normal array notation and dot notation, right? Now, there is one common scenario, right? You might need to explode the array. You cannot go one by one array, right, and get the cities, right? So assume you want to explode it, right? So by default, what we know is we have a function known as variant explode. However, variant explode is a table valued function, right? So if you use directly variant explode, it will never work, right? So what we will do is basically we have to use the lateral explode kind of a syntax. So if you see here with this query, right, you are able to explode the data. So I am going to explode the variant data. So when you use the variant explode outer command to explore the data, what it will do is it will basically create or filter. So I'm filtering for the row number 2, right? So it will get that particular row and it will convert your corresponding columns to one rows. Say address is one of the row and your id is one of the, so whatever column you have in the JSON, right? So I have id, name, version, and then the address. So each column in the JSON will be converted to one row, right? So now here, if you want, right, again you can maybe select file name, right, underscore metadata dot file name, right? You can use this so that later you can do a group by query, and you can probably group it accordingly, right, to maybe convert it to a transpose it, right, from column to row, right? Now this is for your JSON data. Suppose let's assume, right, we have an array and that array we have to explode, right? So for example, we have two addresses, right? Unnest the array. So for nesting the array, it is the same syntax. Just you will have to filter for that particular column, right? You have to go to that array using that notation which we discussed earlier, right? And we can get, right? So another one problem is, right, let's assume, right, you try to get the column and you want to filter it, right? So if you want to filter or cast it, you might need to know the data type. So suppose, let's assume, right, somebody tried to cast something which in version 1 it might be correct, but whereas in version 2, right, it might not be correct. So if you see here, right, we have a address one which is an array or a struct field. So but when we try to convert it as a int, right, it is failing. So what we can do is you can use the try variant get function. So what this will do is it will get your column name, it will get that path, right? From the dollar is the root path. So from like root path, you're querying dot address of one, and then you're trying to convert it into int, right? But however, the address column, as you know, it is a JSON data, so it will safely come out with null, as you see here. Now, next thing, right? Let's assume, right, you want to basically do a casting, right? So you can also do the same, and then you can convert to a normal array field, right? So let's assume, right, you know the schema is of a particular type, and once you filter for a version 2, you can do the normal array operation. Say if you want to do a higher order functions using array, right, you can basically convert it to a array. So if you see here, I am converting that to a array. So this will be a normal array, right? You can use like this as well, right? And finally, there is something known as shredding in your variant. So shredding in high level, what it means is, right, it will basically store the data in a optimized way. Maybe I'll show the representation. For now, you can understand, like, if you create a table with this shredding property, and if you load the data, what it will do is basically it will create the stats for the columns, right, separately, or it will store it in a more efficient way, right? And it will allow us to query better, right? Now let us go and see, right, the variant visual, right? So let us see the back end, right? How does it basically achieves, right? So without variant, you are not able to do the schema evaluation, right? You cannot store multiple schemas. Now let's see how it is happening, right? So let us take a simple visual for two columns, right? A, there is a JSON with A with value SS and B with MM, right? So what it will do is, right, instead of storing the JSON data as is, right, it will store it little differently. So let me show you. So if you see here, right, this is the plain JSON form where your data, right, it is stored directly, right? If you see here, it stores the data as string, and then it has to basically match to a particular schema, and it has to basically bring the entire JSON row in memory to basically find your object, right? Whereas in variant encoding, right, it still stores the JSON data, but it stores differently. Instead of storing the JSON as is, it decomposes into two things: metadata and then your field offsets. So what it will do is, for a particular column, right, say A is there, it will basically know for the column A, right, this is the place where the value is getting stored in the table, right, like in the value column, right? So it will keep like a pointer, so which will ensure that when you query this column, right, you will quickly, you can go to that particular offset, right, and then you can get the values, right? Let us see how. So there are two components, right, metadata and then your value. First, metadata, right, it is simple. So metadata is nothing but it holds basically your variant or your JSON, right, can be of any type. It can be a simple type or it can be a complex type, right? So it will hold all the keys in your variant, right? Say I have like two fields, right, A and B. So for how many fields are there, for each field it will basically store the unique key names. So assume if you have a complex JSON, right, which is having the same fields repeated again and again, you will see a good space savings here, right? This is one of the optimization, right? And again, it stores the offset. So that offsets will be nothing but the point where actual data is getting stored, right? Or this offsets will be nothing but your pointer to the value. So when, like, say we have two fields, right, one is A and B, so the corresponding offsets are 0 and 1 and 2, right? So these are the offsets where you have the actual field name, and these are the fields, right? Now when you go to the value variant, right, you will basically come to know at this particular point, right? So if you see here, right, you have the metadata id 0, right? This is where the offsets are, right? So you don't need to parse the entire JSON. Instead of parsing the entire JSON, it will store the values basically. So in metadata, it stores the metadata about your keys. So this offsets here refers to the key here. So at offset 0, the value A is having the value of basically 0, field 0 is A. For example, if my key is something like ID, right? Zeroth offset will be ID, right? And one offset, like offset one, will be nothing but your say name, right? So such a way it will store the offsets so that it knows exactly, right, what is the field 0, what is the field 1, and what is the field 2. Now when it comes to the value component, what it will do is, again, this is a binary data where it will store the type of binary data, right? It can be a simple struct, right, simple JSON, or it can be a nested JSON. So that is stored in your field metadata, right? And it is whether it is sorted or not, all these offsets related informations are stored here. The key thing which you have to keep in mind is when you have the object value, right? So in that value component you have three cases, right? It will store exactly, right, what are the values, like the number of elements which are there, and the corresponding field IDs. So as we see here, right, metadata we are storing as 0 and 1, right? So for the zeroth field, where is the value offset starts, and for the one field, where is the value offset starts, right? So for field 00, it starts at 0, so it has three characters which embed the SS. From 3 to 6, right, it shows the second value. Now if you think in the bigger picture, right, if you want to query for say a particular value, right, say under JSON, if you want to query only the value B, it doesn't need to read the entire JSON. So it knows from the metadata that B value is basically 1, and for the field ID 1, the corresponding field offsets will be at 3 to 6, so it will go and directly read the value. By this way, right, it doesn't need to store the, or it doesn't need to bring the entire JSON in memory, right? Now where does threading come into play? If you see this value again there is one more hop is there, right? So it has to go to object value, then it has to get the offsets, then it has to parse. So every time, right, it has to go through this binary, right? But let's assume, right, most of the cases, right, the JSON will be mostly homogeneous, right? So you can add some like representations like int or string, right? You can store those if you know those data types, right? But here it's all stored as bytes. So what the other way is, right, where they will store it as a variant, right? So if you see, sorry, with the shredded thing. So if you see the shredded variant, so how it stores is basically it stores like this, right? So instead of storing it as a binary data, it will store as your direct fields at the root level itself. So if you know A is of type int, right, it will, you can directly go and fetch. It doesn't need to go to the binary, get the offset and fetch. Rather than that, it will go and directly fetch the value. By this way, right, it will ensure that, right, you are adding the data type for your particular byte. So for example, if it is an integer, right, it requires like a, or if it is a character, right, if it is a single character, if you know, or if it is an integer, right, we can compress it, right, and reduce the number of bytes. So this, again, these values which are at the direct level at the root are also will be used in your column pruning and all this optimization. So this will also add additional performance benefit, right? So you don't need to, if it is a, assume if there are hundreds of JSON fields are there, instead of going through this process one by one, right, going to metadata, get fetching that metadata value, right, so basically you don't need to go to the extended process. Assume like directly you can go and then fetch it like with a direct dot notation, right? So with this, right, we had seen how to query the variant data, and then how does variant enforce the schema, right? I mean, how does it ensure the schema is basically dynamically handled, right? So schema is dynamically handled. If you see here, right, for each of the row in your parquet, right, it holds the dictionary like this. So first, assume like first JSON, right, has two columns. So it will store the corresponding offsets, right? The dictionary will have the offsets which says what is my key and where is that, right? And the next one is your actual value, right? So zero offset is for the first key, which is A, which is since it is only one character, the next offset will be your B. So these are my two keys in my dictionary. If you have n keys, right, your offsets will vary, right? And each of this will have a field, so it will start from zero and it will keep on increasing, right? So now when it goes to the value, so assume there is a second dictionary where you have say name, age, and then ID, right? So then the offsets will change for that particular row. So there is no global schema. Every row, right, it's stored as a binary object, and that binary object encloses the metadata of the schema, right? It is self-contained. So with this way, for each row, even there is a multiple types of schema, you will be able to handle it successfully, right? So the same, I was able to read the parquet metadata, right, using my one of the packages. And if you see here, for the first data which we stored, right, in the top, the ID and sales, the data which is here, right, the ID and your customer data. So whatever we have stored here, right, ID and data column, if you see here under the hood, right, it stores like this. ID column which is int, it directly stores as int. Whereas for your binary column, right, the data, I mean the JSON column, it stores two of the values, right. One is data and its data's metadata, which has the metadata component which I described earlier, and then you have the data value. Similarly, it also stores the data, I mean store this for each of the row. So there are two rows either, if you see here, right, like for each of the row, right, you could see the ID metadata will be stored, right. So this way it is able to achieve the performance. So now let us see, right, what are the benefits. So the benefits, right, it will improve your read write performance, right. So variant, if you have very complex JSON, it is not going to store the entire JSON. So it will just store the pointers, and it will also change the keys to a encoding, like it will not store the values or like name. Instead, it will keep field zero, right. So zero will be the value which will be stored in the value, right. It doesn't show the actual key name, right. So that is the space saving. And then schema flexibility, which is already discussed. And we also have shredding options, where if you don't want to bypass this binary, right, I mean bypass this binary parsing, if you want to store certain fields which you for sure know, right, it's a top level field, right, then you can directly store as a shredded option. However, in Databricks currently, right, as far as I saw, there is no way to manually or explicitly specify, right, these are the columns which needs to be stored as shredded. But what they are saying is, if you store as a shredded property, it will automatically add additional columns only to the columns which are at the top level. So for example, if you have ID, name, age, so automatically these columns will be shredded. So this A, like A, B, and E, right, these three are basically at the top level, right. So these will be automatically shredded. But the inner array, if you're having an array of struct or a struct array like this, right, where you are an array or a struct, these columns inside, right, C of X will not be shredded, right. So that's all I have for this video. Do like, share, and subscribe.